AP Chemistry exam is just days away. This is what you need to have memorized before the exam and all the stuff that you just need to let go at this point. My name is Karina. I'm a chemistry teacher turned content creator whose goal is just to make as many students understand chemistry as possible. And I hope you'll join me on Sunday, May 3rd at 8:30 p.m. Eastern Time for a live stream last chance review. I'll answer all those final questions that come in through the chat. I'll share all of my tips, and then we'll also have an overview of the content. I'll go through all of the topics that you're most stressed about for Tuesday's exam. But that's not what this video is about. So let's talk about what you should memorize and what you shouldn't waste your time on at this point. So why are we here? The thing is, time is money. You have no time. The exam is days away, yet you still want to score a 4 or 5 on the exam. So let's talk about how we get there. So what I would recommend is grab a piece of paper right now or have a way to screenshot this so you have all of these in one spot. So you need to know a lot of the basics. So I'm talking about the diatomics, those 7 elements that exist as diatomic molecules when they are by themselves. So I like HUN, I need a Cliff Bar. It's just an easy way to remember hydrogen, oxygen, nitrogen, and then our halogens. The other thing you need to know are the elements with all the funky symbols. Want to hear a joke about sodium? Nah, right? You should know that sodium has the elemental symbol of Na. If you are looking for a quick flash deck to help you just remember some of these, like silver is Ag, check out all of my flash cards. These are all free on Quizlet. I also have a lot of resources on Wayground that you are welcome to use. Another thing to know are the common polyatomics. Don't waste your time memorizing 30 different polyatomic ions. Just know these ones. These are the ones that you're going to see over and over again. If you're in a situation where you need to find the charge of that polyatomic ion, you can always work backwards. Look at the cation, hope that it's not a transition metal ion, and then use that to figure out the charge of that anion. There is one that is a cation, that's ammonium. It has a charge of +1. Another thing that's useful to know are the oxidation numbers. Some of these you are so used to because you've seen them over and over and over again, but it is helpful just to have these in the back of your mind. Oxygen is always -2, hydrogen is typically +1, alkali metals in that first column are +1, alkaline earth metals are +2, and then the second to last column where we find the halogens, those are -1. So those are just some of the basics that are going to be helpful as you sit down to take this exam. And then here are some of the random facts that you just need to know. So for some reason, College Board really likes covalent network solids. So these are molecules that are covalently bonded, but then they form this network. It's almost like a crystal lattice, right? So because of that, they're much stronger bonds, and it's going to take a lot more energy for these substances to undergo phase changes. So the examples that you need to know are diamond, graphite, quartz, and SiO2. For some reason, that's the one that we keep seeing on the FRQ. So know that that is a covalent network solid, and that's going to be the reason it's going to have a much higher boiling point compared to just a typical covalent molecule. Another thing to have memorized are the different types of spectroscopy and the different transitions that they measure. So with UV vis, we're looking at electronic transitions, so jumping from the ground state to the excited state, what you looked at in flame test in Chem 1. Microwave spec, we're looking at rotational energies. That's the spin around the axis of the molecule. IR spec, we're looking at vibrational energy. So that's the bending and stretching of bonds. Memorize those 3 so you have them. And if you have a clever way to remember this, please drop it in the chat so we can share this with everyone else. Another thing you need to know are all of the conditions that are listed as thermodynamically favorable conditions. So know that a negative enthalpy, a positive entropy or an increase in entropy, a negative Gibbs free energy, an equilibrium constant that favors the product side and is greater than 1, and then a cell potential that is positive. These are all the conditions that indicate that a reaction is more likely to be spontaneous. All right, moving into solubility. What I want you to focus on is what is always soluble, and it is just these couple things. So group 1 ions, nitrate, acetate, and ammonium. These are always soluble. So when you look at a precipitation reaction and you're trying to discern between 2 products and decide which one is the precipitate, you're going to see KNO3 and you're going to think, oh, I know that this is soluble because it contains that group 1 ion and a nitrate. So always identify the product that is aqueous or soluble, and then you're left with the other one. It has to be your solid precipitate. Don't worry about any solubility tables or NAGSAG PMS Castrobear. Save that for Gen Chem. This is all you need for AP Chem. When it comes to solubility, I do recommend just memorizing the KSP values. You can get to each of these, by just filling out a rice table, right? You can figure this out on your own. But again, time is money on this exam. So if you can just have these in your head, we typically see a 1-to-2 ratio, but it's good to know all of them. It is helpful. And I do predict that we are going to see a KSP question this year. All right, moving into kinetics. Knowing the integrated rate law graphs is important because you are pretty much guaranteed to see either a multiple choice question or a portion of an FRQ that's dedicated to this. What you're going to look for is a linear slope. So if it's just the concentration of the species over time, and that's linear, that indicates a 0th order reaction. It's a natural log, then it's a first order reaction. And if it's 1 over the concentration, that's a second order reaction. Notice for the first two, we have a negative slope. That is equal to negative K, or the negative rate constant, versus with a second order reaction, that's where we see a positive slope, and that slope is equal to plus K. Done. Here comes acid-base chem. So if this is something you are still struggling with, check out a lot of my resources. I have a free problem set. I have tons of videos on this because this is the hard stuff. So let's talk about what you need to know to help you out. So you need to know the 7 strong acids. These are acids which by definition completely ionize or separate in solution. So you put hydrochloric acid in water, it's all going to separate into H plus and Cl minus ions. So we have the halogens minus HF, we have nitric acid, sulfuric acid, and then HClO3 and HClO4. So memorize those 7, and then also memorize that hydrofluoric acid, HF, is weak. You do not want to mess that one up. And then the strong bases, thankfully, are a lot easier to memorize. Those are going to be the group 1 and 2 hydroxides. So anything from those first 2 columns, when they're combined with hydroxide, they're going to do the same thing. They're going to completely separate in solution. And let's face it, acid-base chem is the hardest unit in AP chemistry. So here are some hacks just to help you as you are tackling those really tricky FRQs. The first one is you want to remember the pH is equal to the pKa at the half equivalence point of a weak acid strong base titration. So what that means is that at that point in the Henderson-Hasselbalch equation, your concentration of weak acid and its conjugate base are equal. So therefore the pH is equal to the pKa. College Board loves to ask about this. All you have to do is look at your graph, head over to the y-axis and pull that pH value because that is your pKa. When thinking about the relationships, the higher the Ka, or the acid dissociation constant, or the lower the pKa, the stronger the acid. Because again, the Ka measures the concentration of those products, so the H plus and the conjugate base, over the initial concentration of the acid. So again, the higher the Ka, the stronger the acid. The stronger the acid or the base, the weaker its conjugate acid base, or inversely, the weaker the acid or the base, the stronger its conjugate base and acid. Just a few more, hang in there. So now if you're choosing a buffer, look for a weak acid in its conjugate base or a weak base in its conjugate acid. An ideal buffer will have equal concentrations of each of these because that's how it's going to have the highest buffer capacity or be able to neutralize the most strong acid or strong base. If you are choosing an indicator for a titration, you want to look for a pKa value that is closest to the pH at the equivalence point. You are likely going to be given that. You're going to be given a table of values. You're just picking the one that is closest. All right, electrochem. Hopefully you're looking at these pictures and you know exactly what I'm about to say, right? These are just mnemonics to help you sort through electrochem. Everything is counterintuitive in that, so it does help to have some of these memorized. So oil rig oxidation is loss, reduction is gain. We're talking about the transfer of electrons here. And then we have a red cat and anox. Reduction, or the gain of electrons, occurs at the cathode. Oxidation, or the loss of electrons, occurs at the anode. So I have been doing this for a long time and I still catch myself using these mnemonics and referring to these. So have these in your head, write them on your scratch paper so you don't mix things up. Other tricks when it comes to electrochem, remember that electrons come to the cathode and they move away from the anode. Additionally, as the cell operates, the cat gets fat. The cathode is going to accumulate mass as long as it is not an inert or non-reactive electrode, that is. All right, and now we are moving into the equations that are not on the formula sheet. Most of these are just kind of like rearrangements of the equations, but again, time is money, so let's talk about them. This one, unfortunately, is not on the equation sheet, and it should be. If you think about when you're calculating delta H, delta S, delta G, it's always the sum of the products minus the reactants. When it comes to bond enthalpies, that is not the case. It's going to be equal to the sum of the bonds broken minus the sum of the bonds formed. So in this case, it is reactants minus products. Do not forget that. Do not get this mixed up. You will probably see this. Error analysis is also not on the formula sheet. These are pretty straightforward. You want to remember that the theoretical or actual number always goes in the denominator on the bottom. The order in percent error does not matter because you're using the absolute value. And really, you want to think about, okay, what's ideal? We want the highest percent yield, so as close to 100% as possible, and the lowest percent error, because obviously we want to keep that as close to 0 as possible. All right, cell potential. This is another annoying one that it's not on the formula sheet, but the cell potential is equal to the cell potential at the cathode minus the cell potential at the anode. So if you're given a table of reduction values, just use the values as is. If you have flipped one and you have the oxidation value instead, just change the sign, make that a plus sign between them. All right, so talking a little bit more about Unit 9 in thermo, you're going to have delta G equals negative RT ln of K on your formula sheet. You do not have the version on the right side of the screen though. So this is just, I just move that natural log around so that we're solving for K. We have seen this on there. You could potentially rearrange the log and still solve for K, but I think it's just easier to memorize this version of the equation. If you're looking for some other ones, I have this linked. This is just like a one-pager with all of the things that are not on the formula sheet. Again, a lot of these are just rearrangements. We now have the ideal gas law. Sorry, the combined gas law is now on the formula sheet. So ignore that one on the bottom left. I'll have to update this. All right. Now let's get into what not to memorize. Again, we are days away, maybe hours away. I don't know when you're watching this video. Don't waste your time on these. Do not worry about all of the arrows associated with periodic trends. Knowing the arrows is going to get you nowhere on these FRQs and MCQs. You need to be able to justify everything, and everything goes back to the atomic radius, Coulombic attraction, effective nuclear charge. Know those terms, know how to justify these trends rather than just memorizing how the arrows shift. The other thing you're not going to stress out about are sig figs. There is one point dedicated to sig figs, and it's usually attached to a measurement, like reading the volume of a burette. I should also mention units. Unless the question specifically mentions units, like for the rate constant, like we talked about, you're not going to be penalized for not including units. I think it's a good habit to always include units because it's a good way to check your work. But, it's one of those things that you're not actually going to be assessed on that. So don't waste your time. All right, this might be a little bit controversial, but if you don't have these memorized yet, just don't waste your time on this. It's going to be a max of 1 or 2 questions. A lot of times we're looking at something that's tetrahedral. We're not really looking at the trigonal bipyramidal or square planar shape. So I would not waste your time on that. And then additionally, do not waste your time memorizing anything on the equation sheet or on the periodic table. These are tools that you're going to be given for a reason so that you don't have to memorize all of these. And when you find yourself getting stuck, use that equation sheet. Look at all of the constants that are given. Look at the units associated with those and kind of work backwards. It's amazing how much you can figure out just by looking at the units in chemistry. All right, if you have any other suggestions, please share them in the chat. Again, the goal of these accounts is just to help as many students as possible. So if you have a tip you want to share, please share it. All right, let's talk about some takeaways. So first of all, keep the unit breakdown in mind. I have a lot of DMs coming in right now asking, do I need to know Unit 8? Yes, you do, because look at the weight of Unit 8. It's 11 to 15% of the exam. You are going to see a lot of acid-base chem on this exam. Everything else, 4 to 5 MCQs per unit. So if you have not learned Unit 9, you could potentially still score a 5, even with missing all of those questions. And I need you to just trust in all of the work you've put into this course this year. This is your chance to show off what you know. There are going to be things that surprise you on the exam, and there might be some content that you don't know. But what you are going to do is you're going to rely on that equation sheet, find the equation that you need, or you're even just going to look at the units associated with the quantity that you're trying to find. That's the biggest hack in chemistry, is working backwards from the units to get to the desired answer. And then when all else fails, just mention Coulombic attraction as much as possible. Thanks for watching. Be sure to follow Chem with Corinne 118 for more content like this.